Section 4.6, Systems of Linear Differential Equations. So just like what we did in 3.12, you will be given two different differential equations. And there are so many applications about two different differential equations. Engineers, we work on these circuits all the time. When we have inductors or capacitors, this is one capacitor, this is one inductor symbol, and these are the material we're actually using for batteries. We're not going to really dip into capacitors, inductors in this class, but when you are taking the circuit in the future, we're getting into this. Let's work on this. So let's take the Laplace transform of the first one, dx over dt s x of s minus x of 0 equals negative x of s plus y of s. Second differential equation, if we take the Laplace transform of that, s y of s minus y of 0 equals to x of s. X of 0 equals to 0. X of 0 equals to 0. Y of 0 equals to 1. I'm going to move this guy to this side. Then x plus 1 x of s equals y of s. And we have s y of s minus 1 equals 2x of s. If we divide both sides by 2 for second equation, we have x of s equals 1 over 2 sy of s minus 1 over 2. And we can substitute this x of s into here. We have s plus 1. We have 1 over 2 sy of s minus 1 over 2 equals y of s. We FOIL it. 1 over 2 s squared y of s negative 1 over 2 s plus 1 over 2 s y of s minus 1 over 2 minus y of s equals to 0. Combine all those y of s terms. 1 over 2 s squared plus 1 over 2s minus 1 y of s equals, move the rest to the other side, 1 over 2s plus 1 over 2. And we multiply 2 everywhere. Then s squared plus s minus 2 y of s equals s plus 1. And then y of s equals s plus 1 over s squared plus s minus 2. And then denominator is a factorable. You need to factor them out. And using partial fraction to separate them. And then take the inverse Laplace transform of that to get the y of t. And this technique is okay, especially for if we have just only one prime, like a d over dt, d over dt. But it's going to be really complicated if we have, for example, so many terms or square terms. So what I'm going to do, instead of substituting all of this, we're going to use Cramer's rule. Once we have this, the first equation is s plus 1 x of s minus y of s equals to 0. And then second one, negative 2 x of s plus sy of s equals to 1. We want to find the delta. Delta equals s plus 1, negative 1, negative 2, positive s equals ad s squared plus s minus bc 2. That is s plus 2 s minus 1. We want to find delta 1. First column is going to be 0, 1. Second column is going to be the same. AD minus BC. And then delta 2. First column is s plus 1, negative 2. Second column is going to be 0, 1 equals AD s plus 1. Now, x of s equals delta 1 over delta, and that is 1 over s plus 2, s minus 1. We need to separate this, so using partial fraction, s plus 2 plus b, s minus 1. Numerator is going to be a and b because the denominator is s to the power of 1. 1 less power, so numerator has to be s of 0, which is 1. So we can put a and b. If the denominator is a square term, numerator, when you work on the partial fraction, you have to put in as plus b or cs plus d. Have a common denominator, s plus 2, s minus 1, numerator a times, I have s plus 2, so I need s minus 1. So as minus a. For b term, I do have s minus 1 in the denominator, so I need s plus 2, bs plus 2b. So this numerator, as minus a plus bs plus 2b should be equal to 1. Therefore, s terms a plus b is going to be 0. Constant term negative a plus 2b equals to 1. If we add, we have a 3b equals 1. That means b equals 1 over 3. Then a has to be negative 1 over 3 because we need to add a and b. Then gonna get 0. That means we have x of s as a negative 1 over 3 times 1 over s plus 2 plus b 1 over 3 1 over s minus 1. Now we are ready to take the inverse Laplace transform. Now we have x of t equals to negative 1 over 3 e to the negative 2t plus 1 over 3 e to the positive t. For y of s equals to delta 2 over delta 2, s plus 1 over delta, s plus 2, s minus 1. Again, we need to do the partial fraction, a over s plus 2 plus b over s minus 1. That equals s plus 2, s minus 1 as a common denominator in the numerator. S minus a plus bs plus 2b. This equals to this. This time, a plus b, the s term equals to 1. Negative a plus 2b equals to 1. And we're going to add 3b equals to 2. B equals 2 over 3. That means a has to be 1 over 3 because add them up be 1. Y of s equals to a 1 over 3. 1 over s plus 2 plus b 2 over 3. 1 over s minus 1. Now we are ready to take the inverse Laplace transform. Then y of t equals 1 over 3 e to the negative 2t plus 2 over 3 e to the t. Problem 4.6.4. You are given two differential equations. Solve the system of equations using Laplace transform. So the first equation, we have s, x of s minus x of 0, dx over dt plus 3x of s plus s y of s minus y of 0 equals Laplace transform of any constant don't write in here 1 to take the Laplace transform of 1, which is 1 over s. So we have everything is in s domain. And then second equation, we have x of s minus x of 0 for the dx over dt minus x of s plus s y of s minus y of 0, that's the dy over dt, minus y of s equal e to the t. We take the Laplace transform of e to the t, that is 1 over s minus 1. Initial conditions, x of 0 equals y of 0 equals 0. Everything is 0, 0, 0, 0. Let's combine x terms together, y terms together. X of s from the first equation, we have s plus 3 x of s, and then plus s y of s equals 1 over s. And then second equation, we have s minus 1 x of s plus s minus 1 for y of s equals 1 over s minus 1. It is kind of standard form so that we can put this into the delta 1 and delta 2, meaning everything x and y to the left hand side, no x over y on the right hand side. So the delta equals s plus 3 s minus 1 s minus 1, that equals s squared. So s plus 3 times s minus 1, I'm going to just boil it, expand it. S squared plus 3 minus 1, so plus 2s minus 3 minus bc s squared minus s, that equals s squared plus 2s minus 3 minus s squared plus s equals 3s minus 3. Delta 1, the first column is going to be 1 over s, 1 over s minus 1. Second column, s minus 1, ad, s minus 1 over s, minus bc, s over s minus 1. Want to make a common denominator, s minus 1. Need to multiply s minus 1 minus s squared equals numerator s squared minus 2s plus 1 minus s squared, denominator s minus 1, that equals s squared cancel, negative 2s plus 1, and then s minus 1. And then delta 2, first column s plus 3, s minus 1. Second column 1 over s, 1 over s minus 1. ad, s plus 3 over s minus 1 minus bc, s minus 1 over s. So common denominator s times s minus 1. For the numerator, s plus 3 times s minus s minus 1 square. That is s squared plus 3s minus s squared minus plus 2s plus minus 1 over s times s minus 1. And then we have a 5s minus 1 s minus 1. Then x of s equals delta 1 over delta 1 negative 2s plus 1 over s minus 1, and 1 over delta 1 over 3s minus, that is 3 times s minus 1 squared for the denominator. Numerator, negative 2s plus 1. And y of s, delta 2 over delta. So delta 2, 5s minus 1 over s minus 1. delta 1 over 3s minus 1. Denominator 3 times s minus 1 squared. Numerator 5s. So now we need to do the partial fraction. Let's do x first. A over 3s plus b over s minus 1 plus c over s minus 1 squared. This is a repeated term. That's why we don't have to do cs minus d. It's going to automatically take care of doing b over s minus 1 plus c over s minus 1 squared. That equals, when we multiply a times something, okay, b times something, c times something, you have to follow this. Now a times, I have 3s. The common denominator we're gonna have is this. A has a 3s, what's missing? S minus 1 squared plus b. For b, I have s minus 1 in my denominator. What's missing? Missing 3s, missing s minus 1 plus c. For c, I have s minus 1 squared. What's missing? Just 3s. Now, we're going to compare this numerator with this numerator. So I'm going to write negative 2s plus 1 equals as minus 1 squared plus b times 3s times s minus 1 plus c, 3 times s, 3s. You can expand all of this and compare s squared term, s term, and constant term. Or I'm going to just let s equals to 0. Then the left-hand side, negative 2 times 0 is 0. 1 equals 8 times negative 1 squared. And this one will give us 0. And this s will give us 0. So from here, we have a equals to 1. And it is easier and faster than expand everything and compare the coefficients. Second one, by looking at this as s minus 1 squared, I can use s equals to 1, then negative 2 plus 1 for the left-hand side. And the first term is going to be 0. Second term is going to be 0. And then third term, we have a c times 3. And from here, 3c equals negative 1, c equals to negative 1 over 3. And then there's no more magic number by looking at the right-hand side of the equation. We use them all, 0 and 1. So you can pick any number. You can pick, you want to use s equals to 2 or negative 1, doesn't matter. So we use s equals to 2, then negative 4 plus 1. And then we found a as a 1. 1 times s equals to 2. 2 minus 1 squared plus, we don't know the b yet, times 3 times s is 2. And 2 minus 1 plus c is negative 1 over 3. And 3 times s is 2. So left-hand side, negative 3. This is 1 plus 6b minus 2. 1 minus 2 is minus 1. Move it over. Negative 2 equals to 6b. And b equals negative 1 over 3. Y of s equals a 1 over 3 times 1 over s plus b minus 1 over 3 times 1 over s minus 1, c minus 1 over 3, 1 over s minus 1 squared. So we are working on x, not y. Now we are ready to take inverse Laplace transform to find x of t equals 1 over 3, 1 over s to 1, minus 1 over 3 e to the t, minus 1 over 3 s squared is going to be t, and first translation, e to the t. So that's x of t. Now, y of s, I just copied down y of s from up there. So similar way, a over 3s plus s minus 1 squared. So we're going to write b over s minus 1 plus c over s minus 1 squared. And our common denominator is 3s, s minus 1 squared. Now, when we multiply each one, we need to look at the missing terms from the denominator. So we're going to multiply a times, I have 3s, what's missing? S minus 1 squared. Good. For b, I have s minus 1. What's missing? Missing 3s and s minus 1. Good. Plus c, I have s minus 1 squared. What's missing? I need 3s. Okay, here it is. Now we are happy. And this numerator should be equal to this numerator. Therefore, I'm going to write 5s minus 1 equals as minus 1 squared plus b times 3s times s minus 1 plus c times 3s. And let s equals to 0, then negative 1 equals a negative 1 squared plus 0 plus 0. So a equals negative 1. Second magic number, looking at s minus 1. So if we let s equals to 1, some terms gonna go 0. 5 minus 1 for the left-hand side. And then 0 plus 0 plus c times 3 from here. 3c equals to 4, so c equals 4 over 3. The third number we can just use again. S equals to 2. 10 minus 1 equals a, we said negative 1. S equals to 2. 2 minus 1 square plus, we don't know b yet, 3 times s and s minus 1 plus 4 over 3 times 3 times 2. Then we have a 9 on the left-hand side. We have a negative 1 plus 6b plus 8. So it's a positive 7. Move it over. 2 equals to 6b and b equals 1 over 3. Now y of s equals a negative 1. Negative 1 over 3 times 1 over s. B is 1 over 3 plus 1 over 3 times 1 over s minus 1 plus c is 4 over 3 1 over s minus 1 squared. Now we are ready to take the inverse of this to get y of t. Negative 1 over 3, 1 over s become 1 plus 1 over 3 e to the t plus 4 over 3 and 1 over s squared is a t. Translation e to the t s squared. This one is x of s minus sx of 0 minus s prime of 0 plus sx of s minus x of 0 plus sy of s minus y of 0 equals to 0. That's the first equation. Second equation, we have s squared, this times the y of s minus sy of 0 minus y prime of 0 plus sy of s minus y of 0 minus 4 sx of s minus x of 0 equals to 0. Now let's take care of all the initial condition. X of 0 equals to 1. 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 Okay. X prime of 0 equals to 0. And y of 0, -1. Y of 0, -1. Y of 0, -1. Y prime of 0 equals to 5. 5. S squared plus S, okay, X of S. We're working on the first equation, plus S, Y of S equals, move all other terms to the right-hand side, S -1 to +1, +1 to -1 equals just S. Second equation, so it's only 1x. Let's see that. Yeah, -4, -4 S X of S, and then Y, we have S squared plus S, that's that, Y of S equals, we have -S times -1, positive S, move it over, -S, and -5, move it over, +5. This is -1 times -1, +1, move it over, -1. And then -4 times -1, +4, move it over, -4. So we have 5 minus 5 equals to 0. We have -s. And both of these two terms, they all have s in every single term. So we're going to divide everywhere by s. Then we have s plus 1, x of s plus y of s equals to 1, -4 x of s plus s plus 1 y of s equals to -1. Now we can put delta s plus 1, 1, -4 s plus 1, that equals s squared plus 2s plus 1, which is s plus 1 squared, minus plus 4. So the delta is s squared plus 2s plus 5. And then delta 1, the first column is going to be 1, -1. Second column, 1s plus 1. The s plus 1 minus plus 1, that is s plus 2. And delta 2, we have s plus 1, -4, 1 and -1. The -s, -1, minus plus 4, that is -s plus 3. X of s equals delta 1 over delta 1, s plus 2 over delta s squared plus 2s plus 5. You need to look at the denominator. B squared minus 4ac is less than 0. Therefore, we need to do the complete square. S plus 1 squared is s squared plus 2s plus 1 minus 1 plus 5, and the numerator s plus 2. S plus 1 squared plus 2 squared. Numerator, we need to have s plus 1 plus 1. Separate them. S plus 1 squared plus 2 squared. We have s plus 1 plus s plus 1 squared plus 2 squared. We have a 1, but we need 2, so we need to divide by 2. Now we are ready to take the inverse Laplace transform. X of t now equals, so first term is the cosine. So we have a cosine. What is the k? 2t e to the -t. Second one is the sine plus 1 over 2 sine 2t shift by -1, so e to the -t. So that's the x of t. And y of s equals delta 2 over delta 2 -s plus 3 over s squared plus 2s plus 5. So we're going to separate that again. So denominator, we're going to have s plus 1 squared plus 2 squared. Numerator, we have s negative s plus 3. We have a denominator s plus 1 square plus 2 square numerator. We're going to have s plus 1. That is negative s minus 1. So we need to have plus 4. That is s plus 1 square plus 2 square, negative s plus 1, plus we have s plus 1 square plus 2 square, the denominator, and 2 times 2. Now we are ready to take the inverse Laplace transform, and y of t equals negative cosine 2t e to the negative t plus 2 sine 2t e to the negative t.